Electricians are getting breaker sizing wrong, and it's causing nuisance trips, overheating, and failed inspection. If you don't understand this properly, you're going to run into problems on real jobs. Let me break this down. Today we're going through breaker sizing using real examples. We'll cover the 80% rule, the basic, common mistakes, and real job applications in the field. The first thing you need to understand is that your breaker protects the conductor and not the device. And that's where most people go wrong. Their size according to the device instead of the wire. Example, if you have a number 12 wire, then your number 12 wire should basically go on a 20 amp breaker. Oversizing your breakers can lead to serious mistakes. Not just because your breaker keeps tripping, mean that your breaker has to be upsized. If your wire does not match the breaker size, then you cannot upsize your breaker. One of the biggest mistakes I see constantly on the job site is oversizing the breaker to fix the tripping issue. Most people are not aware that you cannot just throw a bigger size breaker on a smaller size wire. It only creates problems and it creates a hazard environment. When it comes to oversizing your breakers, always verify with your oesc 2024 or your NEC codebook. That's where you will find all of your rules that applies to real job applications. Now let's get into the 80% rule. The 80% rule is the most confusing part of the code book that most electricians and apprentices get wrong. A continuous load is anything that's running for 3 hours and more continuous. That's why it's called continuous load. Example, you have EV chargers that runs constantly for charging more than 3 hours. That makes it a continuous load. You also have motors that run constantly for more than 3 hours, constantly. Some pumps, examples, that are pumping out water for more than 3 hours a day. That motor is running continuously for 3 hours, which makes it a continuous load. Another example, you have lighting circuits. Some lighting circuits that you will find in commercial industry, hospitals, and so on, that are running constantly. That's a continuous load. And you also have many more continuous loads that I can mention in the video. But you get the idea of where I'm coming from. Continuous load is basically something that is running for 3 hours and more. Also, if it is sized at 16 amps, if you have 16 amps coming out of it, you have to size it on a 20 amp breaker. So this is where a lot of things looks wrong. You do your installation, you install, let's say, your lighting circuit, or maybe your receptacle circuit, or your kitchen outlet, etc. You leave it for the night and it trips in the morning. That's where you start to have issues. So you see, your breaker doesn't trip just because it wants to trip. Your breaker is detecting something that's heating up and causing the breaker to trip. It's sending the signal back to the breaker. So your breaker is going to trip once it senses you overheat. Example, that's why you see a lot of arc fault breakers are used in homes. Reason being, it's used in homes to protect the circuit, to protect the wire, not the device. When the device starts to overheat, it's going to send current through the circuit back to the breaker, and it's going to do its job, which is it's going to trip out. So a lot of us are under the assumption when your breaker trips, it's actually okay. When the breaker keeps constantly tripping more than once, you have an issue. It's not something that you want to leave alone for a very long time. So always be aware when your breaker is tripping constantly, there is an issue and it should be fixed. If you haven't seen my previous 80% rule video, go check it out. I break it down deeper in that video. Another common mistake that happens a lot on job sites are load calculations. A lot of times, a lot of us are tired, long day at work, and so on, and we decide to do our installation. Instead of using the code book that was provided to us, or even having your pocket code book. Yes, there is a pocket code book that you can actually walk around with, and it's a lot helpful for apprentices who are just coming into the trade also, because it helps them to understand where to find these rules. It also trains them to understand that the code book is where you have to relate to in order to size your breakers accordingly. So a lot of times what happens is we run cable, and instead of double checking into the code book, we take the breaker that we have and we decide to install it, which is wrong. We should be double checking with the code book to size the load accordingly. That's how it normally goes. That's the procedures that all contractors, all electricians will go about sizing the breaker accordingly from the either the oesc 2024 or the NEC code book. That's how you find your rules. Say for instance, you decide to install a large equipment on the job site, whether it be a furnace, HVAC is normally called on bigger job sites, or whether it be some type of machine and so on. You need to know the load. You need to know if it's continuous. You have to size it according to the code book. And in order to size it accordingly, you can find these rules also inside of the code book where these rules will rely. So always refer back to the code book and never guess when it comes to your actual equipment. Matter of fact, anything that you're going to be doing when it comes to electrical, try not to do the guessing game. The guessing game causes problems. It causes, it can cause hazards also. It can also cause serious injuries. So always try to refer back to your electrical code book. When it also comes to troubleshooting, it's something that you want to avoid. You want to avoid troubleshooting at the end of the job. You want to avoid testing your circuits at the end of the job. You want everything to be smooth, the job laid out fine, to pass over to the homeowner or whoever it may be that you might be doing the job for. You want to make sure also that when it comes to final inspection, that everything is perfect. When it also comes to troubleshooting, it's something that you want to avoid. You want to avoid troubleshooting at the end of the job. You want to avoid testing your circuits at the end of the job. You want everything to be smooth, the job laid out fine, to pass over to the homeowner or whoever it may be that you might be doing the job for. You want to make sure also that when it comes to final inspection, troubleshooting can be avoided by doing the job correctly the first time, avoiding lots of headaches, avoiding lots of wasted time, avoiding lots of troubleshooting at the end of the job. It's not worth it. Money being spent here and there just to figure out what the issue is when it could have been prevented. There's many ways of preventing troubleshooting at the end of the job. whether it be by labeling the wires on one side of the end of the circuit going back to the panel with tape, marker, labeling, one on one side, one on the other side, another set of cable labeling, two on one side, two on the other side. It can all be avoided. Simple troubleshooting is not needed and should not be needed for all jobs. And this is where it gets interesting. And this is where I introduce the tool that I normally use on the job site for simple troubleshooting. Simple troubleshooting can become very easy with the correct breaker finder. And that's where it separates guessing from getting the job done correctly in a timely manner. I introduced the KAIWEETS circuit breaker finder, as you can see. So this is the circuit breaker finder that I usually normally test on the job site to save me lots of time. And again, I'm going to show you the transmitter and also the receiver. So KAIWEETS transmitter KT301P. This is the transmitter here. This is what's going to give the signal back to the actual receiver. This is your receiver here. Simple on and off button reset. As you can see, once you turn it on, this lights up green. Same thing with this. Once you turn this on, this lights up this way. To communicate with the receiver itself, you're going to see a mark up here. It's going to be like a Wi-Fi signal. It's going to pick up the signal of the actual receiver. And also this here, you're going to have voltage, line and neutral on here. It's going to tell you if it's a ground fault. Also, it's going to tell you if it's an open line, open neutral, and so on. It's a digital screen, KAIWEETS breaker finder. So this is what I've been using to identify my circuits. Again, this is fast, efficient, no guessing, gets the job done in no time. A job that could have cost you maybe an hour's job, you can knock that job down to about 15 minutes with this circuit breaker finder. Of course, understanding how to use it also is where it comes into play. It helps to make sure that once you have the panel cover open, proper PPE, that you will identify the circuit faster than having the panel cover on. Again, this is how you use turn on your receiver. Transmitter is plugged into the circuit, and you simply turn this on and it's going to simply flash and let you know a red button is going to show up here. That way you're going to know it's on. So again, this is the KAIWEETS tester that I use in order to identify my circuits once there's something going wrong, once I have to troubleshoot, and so on. So again, simple use of it. You plug this into the outlet, you go to the panel, you make sure this is turned on, you make sure your Wi-Fi signal is here, you go to the panel, you scan, you test, correct breaker identified, that's it, you're done. So the fact of the matter is, I've used many different tools on the job site to troubleshoot, whether it be a regular plug-in tester without the transmitter, whether it be an actual other tester that has a transmitter, whether it be by simple taking my two ends of the cable, twisting them together and bringing out continuity with my meter. So again, there's many different ways of troubleshooting, and for me this one works perfect. It identifies the circuit correctly, it gives you no headaches, it gets the job done in no time, and that's the reason why I like to use this tool that I have here. And also anything that saves time and remove guesswork is definitely worth. Understanding the 80% rule is vital. The 80% rule is what makes everything work perfect. The more you have overload, the more you have on that circuit. The more mixed circuits you have on that circuit, the more you're going to have to troubleshoot. The more your stuff is going to be heated up constantly. For example, if you have ever noticed, you have your bathroom lights and so on connected to your actual receptacle. Once you start to use your hair dryer, your light starts to flicker. That's a common example of overloading and so on, and troubleshooting ready to start. So when you see signs like that, it's always best to avoid by doing the right thing and simply using the 80% rule, where you would have 20% left over in that circuit for the circuit to work accordingly, for you to not have anything to do with troubleshooting and testing and so on. Very important. 80% rule comes out of 14-1000 and 8-104. So in today's video, you'd have learned that your breakers protect your conductors, not the other way around. Your breakers don't protect your device. You've also learned that avoid overloading your circuits, which cause troubleshooting. Also, the importance of the 80% rule, which was covered in today's episode. 80% rule is very important to the installation of all circuits. The 80% rule acts as a protector for the circuit when followed accordingly. With 20% left over, is sufficient to do what the breaker needs to do in case of emergencies. Always avoid overloading your circuits, which will lead back to that 80% rule that we spoke about today. So when you look at it, the 80% rule is very important to all circuits when they're being laid out and run accordingly in the field. So again, if you found today's video helpful, don't forget you can subscribe to the channel, or you can become a member of the channel also. Also, don't forget to leave a like on today's video. You can also follow along for my future installs, my videos which are dropped on Mondays, my live streams which I drop on Wednesdays, and my shorts every Fridays and Sundays, occasionally on Mondays. When you do subscribe, make sure your notification is turned to all. That way you receive all of my notifications that comes out. Also, don't forget the next video that's going to be on the screen. Click it and watch the next one coming up, and I will see you guys on the next video. So in today's wrap up, don't guess your work. Work accordingly. Follow the oesc 2024 codebook or the NEC codebook accordingly. Rushing doesn't get the job done faster. Rushing just creates mistakes. Taking your time always gets the job done correctly. Following your oesc 2024, you can never go wrong with that also. If your breaker trips when you turn on your space heater, that circuit is probably overloaded. Space heaters draws a lot of power. That breaker is protecting your wiring. A lot of people think breakers trip because of voltage, but breakers actually trip because of current. Too much load on the circuit. That's why proper breaker sizing and wiring is important for safety. If your breaker trips the second you plug something in, that's usually a short circuit, not overload.
A lot of homeowners think breakers trip because of voltage. Breakers actually trip because of too much current on the circuit.